Welcome students. Today we will discuss another numerical on three moment equation in which end A is fixed and B and C are hinged ends. B and C are hinged supports. We need to analyze this using three moment equation. Now my friends, how many reactions are there at end A? There will be three reactions, 1, 2 and 3. All of us know fixed support will give us three reactions. At end B, two reactions, and at end C again two reactions. So total number of reactions or total unknowns is equal to 7. Total unknown is equal to 7, and total equilibrium equations, we all of us know how many equilibrium equations are there in two dimensional. Yes, two dimensional analysis, total equilibrium equations is equal to 3. Therefore this structure is indeterminate in nature. This structure is indeterminate in nature. So this is indeterminate structure. Yes, my friends, this is indeterminate in nature. Now we have to apply three moment equation. Now answer my simple question once again. How many structures we can apply three moment equation at one time? How many spans? We know we can apply three moment equation to two spans. So applying, I am writing applying three moment equation to spans, applying the three moment equation to spans AB and BC. To spans AB and BC. Applying three moment equations to span AB and BC. I am drawing span AB, I am drawing span BC. Span AB, which is loaded with 20 kilonewton, and span BC, it is loaded with 6 kilonewton per meter. I know the lengths. The length is 1 meter from A. This is A, this is B, span AB, and this is span BC. I am applying the three moment equation to the spans. This is 1 meter and 2 meter, and I know this is 4 meters. I am writing other equations also. Now here the first moment M1 is MA. Second moment M2 is MB. The intermediate moment is MB. The third moment M3 is MC. Right? Three spans, three moment equation. There are two spans. What is L1? Length of the first span, that is 3 meters. Length of the second span, that is L3, that is 4 meters. What is I1? Moment of inertia of the first span, I know it is I. And what is I3? Moment of inertia of the second span, I know it is 2I. Now my friends, can I plot the bending moment diagram? Yes, I can plot the bending moment diagram. I know what is the value of this. It is WAB by L. So 20 into 1 into 2 divided by 3. WAB by L. W is 20, A is 1, B is 2. We know the formula for maximum bending moment. We don't need to calculate reactions and all these things. So 20 into 1 into 2 divided by 3, that is 13.33 kilonewton meters is the value. I know the bending moment diagram for this is WL square by 8. W is 6, L is 4. So 6 into 16 divided by 8, that comes out to be 12 kilonewton meter, a parabola of 12 kilonewton meter which is acting at center. So this is simply supported bending moment diagram. This is simply supported bending moment diagram. Now I need to find out, I'm drawing it once again over here. This is simply supported bending moment diagram. This I am drawing it once again over here. This is 13.33 kilonewton meter acting at a distance 1 meter from left hand side and 2 meter from right hand side. Right? 1 meter from left hand side and 2 meter from right hand side, and this is a parabola of 12 kilonewton meter which is for the length 4 meters. Now my friends, I need to determine the area and I need to determine center of gravity. So what is A1? This is left hand span. So A1 is half base is 3 meter into height is 13.33. My friends, 13.33 into 3, I have taken it 40 because I have not considered higher decimal. There are higher decimals. So 13.33 into 3, I have considered 40. 40 divided by 2. So A1 is equal to 20. Now A3, I know the formula, 2/3 base into height of the parabola. So A3, 3 4s are 12. So okay, 4 into 4, 16 into 2. So that is 32. That is 32. So A3 is equal to 32. 4, 4, 16. 16 into 2, that is 32. Now my friends, what is x1 bar and what is x3 bar? I know x1 bar is located at a distance L plus A by 3. This is centroid and this is centroid. I know the centroid of this is symmetrical figure. The centroid C is located at a distance 2 meter. It is symmetrical. But here x1 bar, I am calculating x1 bar is L plus A by 3. I know the formula for unsymmetrical triangle. It is L plus A by 3. Now L is 3, A is 1 divided by 3, that is 4 divided by 3. So x1 bar is equal to 1.33 meters. So this distance is 1.33 meters from left hand side distance of the centroid. Whereas x3 bar, since the figure is symmetrical, it is 2 meters. So everything is known to me. I am writing the 3 moment equation M1, that is MA, into L1 upon I1. Now what is L1 upon I1? 3 by I. MA into 3 by I plus twice M2, that is twice MB, into 3 upon I plus 4 upon 2I, L1 upon I1 plus L3 upon I3 plus MC into L3 upon I3, 4 upon 2I is equal to minus 6 A1 x1 bar divided by I1 L1, 3 into I, minus 6 into A3 x3 bar divided by I3 L3, 4 into 2I. So I have calculated. Now can I put MA is equal to 0? I am writing the equation. First let me write the equation. I am getting the equation 3MA plus I have calculated 10 MB plus 2 MC, and I have calculated the right hand side. I will get cancelled. I will multiply everything with I. So my I terms will get cancelled. On the right hand side, I am getting an absolute term minus 101.2. Now my friends, look at the boundary conditions. Tell me, can I say MA is equal to 0? Last time we have put MA is equal to 0. Can I say MA is equal to 0? No. Why not? Because A is a fixed support and fixed support can carry moment. Can I say MB is equal to 0? Though it is hinge support, it is internal support, it will carry some moment. So I cannot say MA is equal to 0. I cannot say MB is equal to 0. Can I say MC is equal to 0? Yes, because it is hinged and it is external hinge, and that is why MC is equal to 0. This is the only boundary condition. I cannot put MA is equal to 0. I hope you have understood why I cannot put MA is equal to 0. Because A is a fixed support and all of us know that fixed support can carry moment. So I am applying the boundary condition. Boundary condition is since MC is equal to 0, I am obtaining the first equation 3MA plus 10MB is equal to minus 101.2. This is my equation number 1 obtained by employing 3 moment equation for the span AB and BC. Now my friends, how to obtain the second equation? Now look at the structure. There are 2 spans only, AB and BC. I have applied the 3 moment equation to the 2 span. There is no third span. There is no more span now. Where can I apply the 3 moment equation? I need minimum 2 spans to apply 3 moment equation. I have applied the 3 moment equation to AB and BC and I got one equation 3MA plus 10MB. There are 2 unknowns and there is only one equation. Where can I generate the second equation? I know for 2 unknowns MA and MB I need 2 equations minimum. But here I was able to generate only one equation and there is no more span left. There is no more span left where I can apply the 3 moment equation and generate another equation in terms of MA and MB. मेरे पास span ही नहीं बचा है, मैं कैसे करूँ? In that case, I will do one trick. There is known as imaginary span. Yes, my friends, last time we have discussed there is a concept of imaginary span. We were discussing that I don't have any more spans on which I can apply the 3 moment equation and I got only one equation with 2 unknowns. I need one more equation to be generated, but to generate, वो generate करने के लिए कोई और span तो चाहिए. कोई और span ही नहीं है मेरे पास, एक ही span है. इनको apply कर दिया. I have applied AB and BC, but there is no more span. So where shall the imaginary span taken? Imaginary span should be taken on the side of the fixed support. Let us say this imaginary span AOA, my A is fixed support, so AOA is my imaginary span, and then AB with a load of 20 kilonewton. With AB, I suspect the load is of 20 kilonewton. AB, let there be an imaginary span AOA, yes, this is 20 kilonewton at a distance 1 meter and 2 meter. This is A, this is B. Imaginary span shall be taken besides the fixed support. जहाँ पे fixed support है उसमें एक imaginary span लेना है AOA. Now assume an imaginary span AOA. Assume an imaginary span AOA, so that length of AOA L1 is equal to LO. Length of AOA is LO, and I1, the moment of inertia of the imaginary span is taken to be infinity. The moment of inertia of the imaginary span is taken to be infinity. LO is the length. Now what is for AB? AB, what is for span AB? L3 is equal to 3 meters and I3 is equal to I. That is what we have known. L3 for AB. There is one more span we have assumed, AOA and AB. Now I am applying the equation, applying 3 moment equation to the spans, एक और स्पैन मिल गया हमको, इमेजिनरी स्पैन, 2 spans, applying 3 moment equation to spans AOA and AB. Now AOA and AB, this is AOA, this is span AOA and this is span AB, having a load of 20 kilonewtons acting at a distance 1 meter and 2 meter, and this is AOA. L1 of AOA is LO, L1 AO, L3 is 3 meters. MA, in this case M1 will be MAO, M2 will be MA, and M3 will be equal to MB. MA, the first moment will be MAO, the second moment, intermediate moment will be MA, and third moment, this is AB, third moment will be MB. L1 is LO, L3 is 3 meters, I1 is equal to infinity, this span is of the moment of inertia infinity, and I3 will be equal to I. Now I know this, there is no loading on this, so the bending moment diagram, there doesn't exist any bending moment diagram. For this I know the bending moment diagram is like this. This is simply supported load, so the bending moment diagram is like this. I have calculated this value I have already calculated is 13.33 kilonewton meter, 13.33 kilonewton meter. Now my friends, now can I determine the distance of the centroid from the left hand support? Yes, distance of the centroid from left hand support is L plus B divided by 3. So L is 3, B is 2 divided by 3. So 5 divided by 3, that is equal to 1.67 meters. Naturally, if from left hand side the distance of the centroid is 1.33 meter, we have calculated the distance from left hand side. If it is 1.33 meters, from the right hand support it is 1.67 meters. Now my friends, you will be wondering why for this case I have calculated it for right hand support, because my friends, AB span is now right hand span. In previous case my AB span was left hand span, that is why I need to calculate x1 bar, that is to be calculated from left hand side. Here in this case AB is right hand span, so I need to calculate x3 bar for AB, and which is from right hand support. If this is understood, everything is understood in 3 moment equation. This is the trick that examiners play with the students, and students fall prey to it, that they take x1 bar already calculated 1.33 meter, but my friends, here AB is a left hand span, that's why I have calculated the distance of the centroid from left hand support. Here AB is a right hand span, though the bending moment diagram is the same. AB is the right hand span, I need to calculate the distance of the centroid of the span from the left hand support, and that comes out to be 1.67. So I am writing the equation, 3 moment equation for the spans M1, that is MAO, into L1 upon I1, that is LO upon infinity. Now you must have understood the meaning why I have taken the moment of inertia equal to infinity. because anything upon infinity is equal to 0. Anything upon any value divided by infinity is equal to 0 plus twice mb, twice m2, that is ma. Now m2 is ma in this case. Pay attention. M1 is MAO, M2 is MA, and M3 is MB. So twice MA into L1 upon I1, L1 is LO, I1 is infinity, plus L3 upon I3, that is 3 upon I, plus M3. Now here M3 is MB. Here M3 is MB, that is 3 upon I, M3, 3 upon I, is equal to minus 6 A1 x1 bar. I don't need to calculate minus 3 because I know that is equal to LO into infinity. Everything divided by infinity is equal to 0. Minus 6. Now I am going to put the value. I know the area for this triangle. I know area already calculated. I have calculated this area. Area I have calculated 20. Area is not going to change. Only the x3 bar will change. So minus 6 into 20 into 1.67 divided by 3 into I. Now my friends, I am going to analyze it. This MA is equal to MA into L1 upon I1 is equal to 0. This is 0. This is also 0. This term is 0. So this 3 upon I will get cancelled. This term is also 0 because something upon infinity is equal to 0. So I am going to cancel all these terms. I am getting this as 6MA plus 3MB, and I am calculating on the right hand side, is equal to minus 66.8. This is how I have generated the second equation in terms of MA and MB by assuming an imaginary span beyond A, imaginary span AOA beyond A, having L equal to LO and having moment of inertia equal to infinity. Moment of inertia equal to infinity means if I put infinity in the denominator, everything will be 0. So I got the second equation. My first equation was ready. This was my first equation. 3MA plus 10MB is equal to minus 101.2. This was my first equation. This is my second equation. Now I have got two equations with two unknowns which can be solved, and then I get the value MA is equal to minus 7.14 kilonewton meter and MB is equal to minus 7.98 kilonewton meter. I have solved these two equations with two unknown. I got the value MA and MB. I am representing these values on the structure now. Pay attention. I am drawing the structure again. A simple structure. AB and BC, only two spans over there. AB was loaded with 20 kilonewton, which was acting at a distance 1 meter from left hand and 2 meter from right hand. This is 4 meters. This was 6 kilonewton per meter, AB and BC, and this was the case. And now I am just representing it. I am just representing these moments. MA minus 7.14, minus means hogging. I should represent it like this. This is 7.14 kilonewton meter. MB is minus 7.98, minus means again hogging. So I am representing it on portion BA as well as BC, 7.98 kilonewton meter. And what is that C? C is 0 kilonewton meter. I have assumed, because I have considered that this is my assumption, that since this is external hinge support, the moment is equal to 0. So I have shown these. Now I am going to plot the bending moment diagram. The simple method, last time we have discussed that we will overlap the simply supported bending moment with the fixed ends. So the simply supported bending moment diagram is like this. This is 13.33 kilonewton meter at B is equal to 0, and then it is 12 kilonewton meters and it is 0. So this is 12 kilonewton meters and this is 13.33 kilonewton meter. This is simply supported bending moment diagram. Now I am overlapping the moments obtained through three moment equation. This is negative moment. I am plotting it upwards, 7.14. So nearly half, 7.14. This value at A is 7.14 kilonewton meter, right? At B it is 7.98, somewhere over here. I will try to draw it proportionately. 7.98 kilonewton meter, and I am connecting the dots. And this is 0 at the end. So from this point A to this point, the moment is negative. because 7.14 is more than the simply supported moment, so this is negative moment. From this point to this point the moment is positive, so I am tracing that particular thing from this. Again from this point to this point the moment is negative, I am tracing it, this is negative moment. Again from this point to this point the moment is positive, I am tracing that particular moment. The one which is enclosed in the red is my bending moment diagram, is my bending moment diagram. This is my bending moment diagram, which is overlap of simply supported bending moment diagram with the bending moments obtained through any of the methods. Let it be three moment equation, let it be slope deflection equation, let it be moment distribution, or any other method we have employed. So this is the simplest bending moment diagram. This is the method of plotting simplest bending moment diagram, and then you can always use this method in your examination also. I hope you have understood the speciality of this numerical. In this numerical was न्यूमेरिकल विथ वन एंड फिक्स्ड. जब एक एंड फिक्स हो जाता है तो हमको एक इक्वेशन कब मिलता है? इन दैट केस वी नीड टू प्रोसीड विथ एन इमेजिनरी स्पैन विच शुड बी टेकन बियॉन्ड दिस. इमेजिनरी स्पैन कहाँ लेना है? सी के बाद में नहीं लेना है, एक से पहले लेना है, ए ओ ए. एंड इमेजिनरी स्पैन के स्पेसिफिकेशंस है, द स्पैन शुड बी ऑफ एनी लेंथ एल ओ, but the moment of inertia we can imagine that inertia is infinity, because we know that moment of inertia is in denominator everywhere and everything divided by infinity is equal to 0. So we can get number of equations equal to number of unknowns. So friends, I hope you have understood this particular concept. Next time we will discuss a concept of settlement of support in three moment equation. Thank you.